Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, I'm trying to see how to work with Rust. So in case you want to be a Rust backend developer, I'm trying to see how to do that, right? So this is going to be my journey of learning Rust to become a Rust developer. So we'll be using this wonderful platform, roadmap.sh, and then we pick in backend, and then we are following this particular approach, right? So we are going through the backend route, and you are picking a language. The language you are picking is Rust. So this is the official roadmap.sh/Rust roadmap, and then we're going through this entire workflow to master Rust. So let's see how to do that. So I'll be creating a repository on my JCharisTech repository, and then we will create it, and I'm going to call it as Rust roadmap, right? So let's call it as Rust roadmap, something like this, so that we have this name there. So Rust roadmap, like this. And then I'm going to learn and then mastering Rust as a backend developer. That is the basic idea. So learning, the goal is you're learning and mastering Rust as a backend developer, right? So let's see. I'm going to make it public. I'll add a readme, and then let's add a git ignore, and I'll call it as Rust, right? So Rust git ignore, and then I'll add no license. So let's create the repository. So JCharisTech Rust roadmap. So this is the name we are calling it, right? So I'll just copy this one, and then I'll go back to my workspace here, then git clone. So this is the first workflow we are following. So in case you want to be a backend developer, you have to learn how to use Git, and this is a simple overview of how to use Git. You create a GitHub account. Then when you create a GitHub repository, you come back to your platform or your operating system, then git clone. I'm going to clone it, then I'll move into my Rust roadmap, right? So you can see there's just the readme here. Perfect. So that is the first step. So let's go back here, and I'll open this location with VS Code, and then we'll start writing some code. So yes, I trust this. Then you start writing some code. So the idea behind this is to learn Rust, and then we are using the Rust roadmap, right? So first, what we will do is the basics. So you learn the basics, which include the introduction, and then we also see working with data structures, or the data structures, and then we see how to work with string, and then string manipulation. This is important to understand. And then we also work on the different aspects, right? So like functions, structs, then we see go with the borrower, and then lifetime, right? All of these etc. And then we'll move from here to the application. So we'll be learning it per application, and then we'll first work on web application. So web applications, web apps, then I'll go to CLI, then I'll go to GUI, right? So these are the basic stuff you'll be doing. So APIs, right? So this is how you'll be learning it, and then we'll be learning it in a format of application wise, and then we go with NLP, data science, and then let's say AI, right? Okay, so let's start with it. So first, this is our workflow, and this is our idea, and this is what we'll be using. We are using this particular platform. So let me copy this here so that we have a reference, right? So we just use this one as my reference. It's going to be, yeah, now I'll call it as my Rust roadmap. So Rust roadmap, right? Perfect. So this is where we are going to. Okay, so let's start with it. So what is Rust? We will learn about it on ourselves. Why we use Rust, we will also learn it later on. And let's see the installing Rust and cargo. So to install Rust, I just go back to the official Rust lang, and I'll go to the install, and then this gives us the approach to install. So install it, just copy this, can download, select as downloaded, and I can click on it to install. So I already have Rust, but let's go with yes. So I think I already have Rust, right, installed. Press enter. And now press enter again. So perfect. So I've installed it. So that is all that you need to install Rust on your system. You can also use this one to install Rust for WSL. And then let's see the various tasks we can do. So Rust has very nice tool chain. So we have the Rust app, and then we also have cargo. So these are the main stuff there. So we have Rust app and then cargo. So let's go back here and let's go with Rust C -add version to get the version. So this is the version I'm using. Then Rust app -help. We have the various things we can do, right? So we can show the active install toolchains. We can update, check default toolchain, target component override, run, perfect. And then there is also cargo. So cargo is a very powerful manager in Rust, the Rust package manager that allows you to be able to build, check, clean, create a new project, initialize, add packages, remove, right? So all of these things are very useful. So let's write some notes. So Rust installation and then setup tools, right? So we have what we need is we have the Rust C, and then we have the Rust app, and then we have cargo, right? So these are the most important tools that we need, right? Perfect. So this is very useful. So that is the package manager. Okay, so that is some of the stuff we have done. Now let's go back again and then let's see how it works. So cargo, new, then I'll call that basics, right? So I'm going to create a directory called basics, and this is going to create a binary called basics. And if I check it again, we have my basics, and I can open it with VS Code, or I can go back to my location here. If I come back here, I have my basics. Inside my basics, we have my source directory. Inside my source directory, I have my main.rs, and this is my first Rust hello world, right? So how do we run this? Let's open it from here, and then I'll open my terminal. So to run it, all I need is I can just go back and go with my cargo. So first move into the basics directory, then cargo run. So if I go cargo run, it's going to compile and it's going to return hello world, right? There's a very nice library or package that you need when you are working with Rust, which is called Rust Analyzer. So if I go back to my extensions, I can search for Rust, and then I'm going to get my Rust Analyzer. So this is the tool, right? So this is what you need. Very powerful tool. It's a language server, so ls, language server that allows you to be able to analyze and then work, helping you with your syntax for Rust. And then we also have the official Rust extension, but this is enough, right? Okay, perfect. Let's see some other stuff we need. So we have gotten this. Let's add another one. So we have Rust Analyzer package, VS Code extension. There is also, from what I've learned, there is also Rust Rover, which is an IDE from JetBrains. So in case you don't want to use VS Code, you can also download this, but this is free for non-commercial, and it will give you 30 days without license. You can use it, and after the 30 days you have to get a license. If I go back to the download, you can see free for non-commercial, right? So you can download it and then use it for your work, which you will explore later. So this is another tool you can also use. Okay, so let's go back to our workflow, and then let's start with the basics. So I'll go back here. Then we have seen how to run our code. To run our code, just go with cargo run, and that is how to run the code. So let's start with the basics of Rust. So based on this introduction, we know we have to go through the normal stuff. So this is variables, constant, data types. So let's start with the language basics. I'll go back here. So this is how to print. In case I want to work with a variable, so this is how to create a comment in Rust. Comments, right? And then in case I want to create a variable, so a variable is something that holds data. So to create a variable, just go with let s be equal to 5, right? So this is an immutable variable, and automatically, because I'm using a Rust analyzer, it gives this type here. So this is the type, data type of it, right? So Rust is very, it's a must, right? Not a must, but you should also most of the time give the data type. So if I double click on it, it's going to give us the data type. So this I here stands for signed, right? Integer. So the I here is integer, right? It's a signed integer. So signed means that it has a sign, so it can be either positive or negative, right? So that is the meaning. So signed, right? And then you also have unsigned, which is going to be u, which is unsigned. Unsigned integer means that it doesn't have a sign, so no sign, right? It's only positive. That is the basic understanding. So this I is signed integer and the u is unsigned integer, right? So that's the meaning of it. So signed integer with 32, right? That is 32 byte. Then in case I want to create another one, so this is immutable. So let's create another one. So in case I want to print this, I can just go with print line, and then I can pass in my value here. So we can just do this option here, and I pass in x. There is another way you can print stuff in Rust. So this is similar to f string, right? So in case you're coming from Python, we have the f string format. So you can just put this here, and if I run it again, just go with Rust run, and you see that we have number 5 here, right? So that is how to work with variables. So it's a variable is anything that stores data, right? And then this is immutable, right? So I cannot change it. So I cannot change this s5. I can add some value to it, but it's immutable. So if I go with mutable, so mutable y, then I'll call this one as, let's say, integer 34, 32. Then let's call that 10. And you should always remember to bring this semicolon to end the statement, right? And then if I come down here, you see that now we have this yellow stuff underlined. That means that it has not been used, right? So remove this mut. Variable does not need to be does not need to be mutable, right? So you can just, this is immutable and this is immutable and this is mutable, right? You can just take it off and it's still going to work, right? Okay, so that is how to work with variables, right? So let's see how to also work with numbers. So you have seen how to work with numbers. So all of these things are already stored on the stack. So all the numbers. So we have integer, float. These things are all Boolean. They are all stored on the stack, right? Stack, right? So a stack is like if you have a plate, and then so if any number you put on, so it's like you're stacking. So let's say I have one book here and I have another one, I stack on it, and I have another one, I stack on it, right? So that is like a stack. So it's like first in, last out. So LIFO, FIFO, right? So the last one is the first in, right? It's first out. That is how a stack is. So first is FIFO. So there's last in, first out. LIFO, FIFO, right? That is a big understanding. Now let's see how to create. So let's a be integer. We have seen how to work with integer. So let's say f be a float. So float 64, and I can pass in my float. So the float is going to be, let's say, 10.1. So this is a float, and then let's Boolean. So let's is active. This is a Boolean, right? And then a Boolean is true or false, right? So now I can print line, then I can just follow with this option here, and then this is going to be my f, and that is going to be my is active, right? So something like this, and then I can close this one here, and then if I run it, so the reason we are having this underline is that anytime we use something, right, anytime we create a variable, we have to use it, right? In case you don't want to you have created a variable but you don't want to use it yet, you can just use one unused variable, right, to hide it. Or you can just simply put something like this, underscore in front of it, and then the arrow goes, which is very cool. Now I can go back here, and if I run it, so we have hello world, which is the first test. We have my variables that I redefined, which were integers, and then my float, and then my boolean, right, which is very cool. Now in case I want to check for the data type, how do we do that? So to check for the data type, the simplest way is that you need to use some importing, right? So to import something, I can just go back here, and I'll just go with use. So if I go with use is a way of trying to tell Rust, okay, use something from the standard library. So this is similar to import, and then any. So I'm going to import any, and then I'll just go with the type name. So this is how to check for the type. And in case I want to check for the type for any of them, I can just go with this option. So I can say my type. Let's go with print line. Then I will pass in something like this. The type name. And then I'll specify the stuff I want to check. So let's say I want to check for the type of this, right? If I go with this option here, so it's giving us this error, right? Text things. Yeah. For type name. So what I'm trying to do is this. So let's have the S here, and then let's print it to C. It will give us the type. So saying that it cannot compile basic, and one of the nice thing about Rust is that it's very how do I say it? It is very informative with the arrows, right? So it's telling us, okay, this is the location of the arrow. So unexpected argument of type reference. This is how to do reference, and then this is the integer type. So remove the extra argument. So what extra argument do we need to remove? So let's see if we can take off this. It will work. So sometimes it can be very, very troublesome when you're trying to work with Rust, right? Unexpected. So it's still giving us an error somewhere. So let's go off with this. We can, yeah, let's go for this, something like this. And yeah. So this is one of the ways you can use to check for the type, but later on we'll build a simple function to help us check for the type, right? Okay, so that is how to work with variables and integers, right? You can also do all the numerical additions. So these are all the operations. I can add one number to the other. So let's addition be equal to my y. So let's say x plus 4, and then print line. You can just pass in these values, which is going to be add, and then I can close it. So this is going to add it for us and give us a result. Here we have 9. So you can do addition, you can do all the different operations. So it can be subtraction. If I run it, we get it, right? So all the operations works as supposed to be. Perfect. So that all the different operation works. Very cool. Now there's one more thing you can also do. So you have seen how to work with integer, float, boolean. There is also the option of getting the character. So in case you want to get a character, characters are usually in single quotes. So to get a character, I can just go and say this is going to be C for character, and in case I want to specify the type of character, I can just go with C, right? Then if I put this one into single quote, automatically it is a character, right? If I double click on this, I get the type definition, and I can just print it. So print line. You can print it this way, and it will still work, right? So you can also do it like this way. Then if I run it, so we still get A. So A is a character. So this is how to work with a character. If I put it into 2 here, this is not a character, right? So that's why we have underlined. So this is not a character, this is a string literal. Right, so single quote is a character. Now let's work on an array, right? So we have seen that's how to work on arrays and then tuples. So an array is a fixed size collection, right? So to do arrays in Rust, we just go with let's R or let's array. Then I can specify here, you can specify your value. So let's say 3, 4, 5. So this is an array, and automatically we have the definition. So the first value is that it is an array of integer, signed integer 32, and this is the number of elements there, right? So if I double click on this, we have it here, and then we can also print it out, right? So in case you want to print this print line, if I do this option and I go with array, we have this underlined stuff here, right? So it doesn't implement standard format display. So the trait display is not implemented for array. So how do you fix it? So to fix it, you just have to use this option. That is one of the nice things about using the Rust analyzer. It makes it very easy for you to work. So if I go with this, now we have the display trait. Now I can print this one out. And now we see that we have this array there, right? So this is how to work with an array. In case you also want to work with a tuple, tuple is a finite length sequence, right? Or collection. So fixed size collection, but tuple is mostly immutable, right? You cannot change immutable. So it can be this. So let my tuple be equal to, you always put inside the bracket. So 1, it can be a tuple of character, and I can put in, let's say this is cool, and then I can say let's add another number 78 and then true. So this is a tuple of different elements. You can see that automatically the Rust analyzer gives us the data type. So if I click on it, we have it here, right? And then in case I want to print it, you can also print it the same way. And you have the same error. So it's going to tell us, okay, we need to implement this option here, or this option for pretty print. So let's use the other one. Let's use this for the pretty print. And then we can run it again. And you see that we have it in a nice format. So the pretty print prints it in a very nice different format, right? So that is how to work with most of the data structures, right? Now let's move on from here and then work with the last data structure, which is very important, which is a string, right? So we have strings, which are very important because if how in Rust, what I've learned is that most of the data structures that we had, so we have the boolean, the integer, the float, we have the array, tuple, right? There is also sets, and then there is also dictionaries, which are called HashMap. We also talk about it, right? And then there is vectors. But when it comes to strings are very interesting. So we have the string literal, right? And then we have the string slice, which is represented as this. So these are the types. So you have the string data type, and you have the string slice, right? So this is very interesting to learn, right? Because the string, so let me make it there. So go back, let's save this, and let's go back here. So string. So in Rust we have this option here. So we have this. You have this option, and then this. These are the two stuff you have to know, right? So this one is called string slice, and this is a string, right, for dynamic string, which is mostly for string literals, right? So I can just go back again and do something like this. So let string be equal to something like this. Hello string, right? So this is a string slice. As you can see, it's automatically figured it out, right? And then there is also let line string, which is going to be this option here, string from hello string, right? So these two are similar but different, right? Very interesting. They may look the same in Python or in Go, but here it is totally different. So one is a string literal, and then one is an actual string, right? Perfect. That is something that you have to know about it. So in case I want to print them, I can actually print all of them. I can print the first one. I call it, no, this is not a literal string. It is a, yeah, this is, yeah, it's a literal string, but let's call it as a slice. I hope, yeah, something like this, and then I can just pass in the other one. And if I print it out, so this is hello string and hello string, right? Very interesting. So these are some stuff you have to know when you're working with string, and maybe another time you go deeper into the concept. If we go back and we check the roadmap, we had the variables constant data type, and there is supposed to be a whole chapter on strings, right? Which is very interesting. So we have seen integers, floats, boolean, character, tuple, and array. Now we are seeing string, so later on we'll see how to work with vectors, HashMap, HashSet, and the rest. So with string in Rust, string is a growing mutable owned UTF-8 encoded string type. When Rustaceans refer to strings in Rust, they usually mean the string, and the string slice. Yeah, so if they are talking about strings in Rust, we mean either the string or the string slice types, not just one of those types. Both types are UTF-8. A string in Rust is similar to a string in another language, but it's not null terminated at the end. Creation of a string can be done from the literal string with this option, which we saw, or by converting a string slice to string. So we can convert this string slice to a normal string. So convert string slice to a string, an actual string. We do that with the string slice dot to string, right? So that is how to convert it. So this option, this hello world, we could convert it to a normal string this way, right? So that is one of the ways. So we can do this option. This is a string slice. We can convert it to a string by going with this option here, right? And this is going to convert it to something. So if I go with print line, it will still work. I'm surprised it's not working. Yeah. So this, we are getting this option here, but I can simply fix it with this, and then we get it, right? So this is how to convert a string slice to a string. Perfect. And let's see, so string concatenation and manipulation are achieved via a multiple of objects such as push string, push, and then format macro, right? So these are some of the stuff we can do with strings. So let's see some simple manipulations we can do with Rust strings, and then we'll come back to it. So let's see some of the things we can also do. It's very important to know all of these things, because with time you get to know that that is one of the most difficult stuff to do when you're trying to learn Rust, right? Working with strings, it can be very difficult. So let's see. So I'll go back again to our workspace here. So this is all that we have learned so far, right? Perfect. So let's see. So I've seen how to work with strings. So this is strings, and this is how to create a string, right? So we can create a string using a string slice. We can create it from this option here. We can also create it, right? So these are the two main ways, and then we can convert a string slice to a string. We can also do some append, to append to a string. In case I want to append to a string, I can say, let's say this is my string slice, or let's create another one. So let me create a simple example. So let's call this, okay, let s be equal to a string from, so this is Rust, right? And in case I want to append to it, I can just go with my dot push string, and then I will just pass in the stuff there. So I won't say roadmap. And this is how to do that, right? But as you can see, we are having this error here. So cannot borrow s as mutable. So it is not declared as mutable. So why are we having this error? So you can only, this type of strings are immutable, right? So all of these are immutable. So this is immutable. Immutable. So you cannot change it. So to make it mutable, just mutable via mut, right? So if I put mut here, now this is mutable, and now the error goes. Now I can, because it's mutable, it is changeable, I can append to it, right? I can add some stuff to it to make it mutable right now. So this is how to append to it, and I can print it out. So print line, and then let's pass in here, so s, and if I go back with this, I can print it out. So we see that we have the hello string and then Rust roadmap. Perfect. That's how to append to a string. You can also do push, right? S push is also there. In case you also want to, in case I want to push to s dot push, I can also push dot to it, and this is also another way. So let's copy this one from here. And because the reason this is failing, that this is a character, right? So since it's only one, I can just go with this option, and then it works, right? So I'm pushing the character to it, and if I print it again, so we have the Rust roadmap with dot. So we can use this push string, or you can use this push, right? Any of them will work. Now let's see, how do you get how do you access some of the stuff there? So accessing an element in the string, right? So in case you want to access an element in the string, we can do this option here. We can do, let's say, for I in just like a for loop, s dot split. Then I want to split the entire stuff per space. Then I can say print, not print line, but print that particular I here, right? And now I can loop through the entire stuff and return all the values there. So you see that we have Rust roadmap and Rust, right? So this is access an element by looping through it. We can do this approach. There are many ways you can also do it, but later on we work on it. You can also use accessing via range. which is going to be something like this. So I have my print line, then I say I want to get the first one, so s.get. I want to get the first two values there, so I can just go with 0.2. That is how to get the range, and then I can just go dot unwrap. Unwrap means that I can accept no value. That's why I'm using the unwrap. And then if I run it, we are going to get, let's hide this. We are only going to get the first two, right? So 0, 1. So this is the meaning, right? So this is how to do range, right, in Rust, right? Very cool. You can also try it in a different approach. So I can also look through the entire stuff using this approach here. So what I'm doing, that for I in this S, I want to loop through it till the length of that particular value, and then I can print the character that I want. Instead I have u. Very funny, right? I'm printing the values there. Cool. Let's see how do we do some replace. How do we replace? Or let's see, how do you search for a term in a string? So today I can just simply do something like this. So I can do print line, which in our case I can say, okay, does S contains the word, let's say RU, and I can do that, right? And if it contains that, it's going to return that particular value, right? So let's run again, and it's that false, right? So this is one way you can search for a term. And it's if I change it to R, so it's true, right? So this is another way you can also do those things. You can search for a term using S contains. In case you also want to replace, you can do something like this. So let's say let R1 be equal to the S dot replace, because for you to be able to replace something, you have to make sure that this value is mutable. Then I can say, okay, I want to replace the word. Let's see the word we have. We had Rust. I want to replace the word Rust. So I want to replace this Rust RU with something different. So let's replace this one with, let's say, row, right? And then I can now print this. So now it replaced Rust, which was the first word we have here, with roast, right? So that is one way you can also replace a term. Notice that all this replacement you are doing it on my mutable string, right? And remember that if you have a string slice and you want to convert it to this format, you just have to do toString. Perfect. Let's see some other stuff you can also do in case you also want to find a particular value, right? Check and see if the value exists or not. You can use this. So you can use find. This is how to find something. So in case I want to find, let's say Rust or whatever it is. So let's say hello. This means that, okay, provide a default value when the option is none. So in case this unwrap means that if there's none, return this default value. So if I run this one, if it is none, it's going to return 0, right? But if I change this one and I put the rs there and there's a value, it will return 0 again. But if we find this here, so now it still did not find it, right? Very cool. So funny because you have mutated it somewhere. Right, perfect. So this is one way we can use to find something in Rust. Let's see some basic transformation you can also do. So example is if I have a value, so let's go just say let s2 be equal to my string from this transform test. So I have this test here, and in case I want to convert to lowercase, I can just do, s2 dot to upper. Right, if I do to upper case, this is supposed to convert this entire stuff to uppercase, but you can see that we have this error here. So the reason if I try to convert this string to an uppercase, let's see the error we are going to get. So let me hide all of this. So I was able to transform the entire stuff to uppercase, right? So very cool, very nice. So that's how to convert to uppercase. I can convert it to lowercase. See, that's converted to lowercase. I can also convert it to title case, and the rest, right? But most of the time, upper and lower is what I know of, right? Okay, let's see some stuff. So this is the basic ways you can also work with string. Now there are some basic stuff we can also do. One of the other transformation you can do is that we can concat, right, strings together. So let's say I have let s3 be equal to string from new test. So in case I want to concat the two of them, there is one way I can do that. I can just simply do first method, right? This is the first method. I can simply do something like this. So s2 and then s3. So let's call this s3. This is one way we can do that. The other way that we can also use something like the format. So s4 b, or let's go to concat s. We can do format, and then with the format I can also do the same thing. I can just pass in my s2 and then s3. So this is another way. So you can either use this option here, right, or you can just use this option here, and I can now print line this, which is right. So this is one way you can use this option. You create a string, use a print to concat. We can just use this option, use format to concat. So this is another way you can also do that, right? So these are some of the ways you can concat strings together. Right, so that now it has concatenated them perfectly together. Perfect. So how do you split, right? So in case I want to split, we can also split, right, a string into some. We can trim. In case I have some space here and I want to trim it, I can just do the same. So if I want to trim this, I can simply do my s3 dot trim, right? So you can actually trim, right? You can also trim it out, and it's possible for you to also get all the characters from it, right? So just as we saw here, initially we saw this approach in which we access elements using this option here. We can, instead of doing this, we can also do something like this. So we can do something like, you don't need this. For C, in whatever string we had, then to chars. So this is very important. So it's going to convert the entire stuff to characters, and then I can now print it out. So print line, then I'll just pass in. So this is another way. So what this one here was okay, but we can also do this. So this is in case I want to split, but I can do this option here to get all the characters of it. So that we got all the characters, as you can see. So all the characters are here, MAP, and then we also have the trimmed test here. Okay. Okay, these are some of the stuff we have learned with strings. So there are so many things we can do with strings, but with time you just go through it, right? Okay, we are done with strings. Let's move on to vectors. So what is a vector? So a vector in Rust, often referred to as vec, is a growable, dynamically sized array-like data. So there is array, which is fixed size, and there is vector. So vector can grow, right? So it stores elements of the same type in a contiguous block of memory with a count of elements and a capacity managed automatically by Rust. Unlike arrays, vectors do not need to have a predetermined size at compile time, and their size can be increased or decreased at runtime. The vec generic t, this means generic t, holds its data on the heap. So we have the stack and the heap. So vectors store their data like strings. They store their data in the heap because it has a growable, dynamically sized array. So if I go back and I check this one here, it's a growable. So anyone that is growable, that can grow in the size up and down, we mostly store it in the heap. But if it is a fixed size, we store it inside the stack, right? Because it's a stack, you can actually know the size of it. But with anything that is growable like vectors and string, we store it in a heap. Okay, so the length is the number of elements stored in it. So let's go back again to our workspace here. So this was the concat with strings. Now do that. We have seen how to work with strings. Just as it's growable, right? You can also get the length of it. So this we forget to do. We can do this. It's dot length, right? So this is going to give us the length of the string, right? Remember that there was something like that we did previously, which was here, in which we were able to get the length. So you can actually get the length of a string using this approach, right? And there is the approach. So let's go back to vectors. So as I said, a vector, from what we learned in this place, is a growable, dynamically array size that can store homogeneous, right? So let's see, how do we work with vectors in Rust? So let's start. How do we create a vector? So we can have my first vector. So let's go to select my odd vector, which we can now go straight away and specify that vec. That is how to do that. So vec, then new. This is the simplest way to create a vec, right? So first you just create a vec with this, saying that okay, type annotation needed for vec t. So we need the type, right? Type must be known at this point because it's a growable, dynamic size array like that can store homogeneous same type, right? So now I can have to specify the type here, and we do that with this option. So vec, then I specify the particular type. So I want integer 32 unsigned, and if I save it, now the error is gone. I need to use it, right? So how do I add elements to a vector? To do that, I just go with my odd vec. Then we have push, right? So I can push 1 to it, and then this is going to push it there. But it's saying that okay, cannot borrow. So odd vec as mutable, right? So we need to make sure that this is mutable. We can change it, right? So to make it mutable, we just have to put mut in front of it, and now we have seen how to create a mutable variable, or which is a vector, and we have seen how to add an element to it. So now if I print this, we are going to get an error. So the reason we are getting an error is that this vec doesn't implement this standard format display. So since it doesn't have that trait, we need this format to be able to print it, just as we did for the other collections like the array and then the set and the tuple, right? So we also need this option here to be able to get the traits. So if I run this, now we have my number that I pushed there. So the number I pushed was 1 and it's there. So this is how to add an element. In case I want to add an element by extension, I can also do vec.extend, and with the extend I can put in some value. So 3, 4, 2, right? So this is another way. So if we can push, we can extend, and you can see the difference if I run it. Then now we have 13. Right, so we had the first one, so we have 1, 2, 3, 4. So this is how to add an element to it. So this is one way of creating a vector and then add an element. The other way we can also do is like this. So this is method number 2. We can do it this way. We can create a vector like this. So let odd mutable odd. So even vector. And then we can simply specify that we want a vec of integer, say 32. And then I can simply do with the vec macro. So this is using the vec macro. And here it takes in the value. So say 2, 4, 6, 8, 10. Right, so this is, let's go with this option here. 5 and then 9, 7, right? So that is, it makes sense. So this is how to create a vector. The vector macro, we are using the vector macro, right? So this is the simplest way. So the vector macro is this option here, the vec with exclamation. And this is one of the simplest way. Either you define it this way, you initialize a vector, then you push your element into it, or you just create a vector and then you just push the element in it. So both of them works. And now I can also print it out in case I want to get, so let's print. We have it working. In case I want to access, how do we access a vector element? So how do we access the element within them? So we can simply access the element within them with this option here. So there are two ways. We can do this option here, as we saw. So we can use this option, as we saw, to print the entire stuff, or we can use first to get the first element, and then unwrap means that, okay, unwrap means it may return none, right? Optional, hence we use the unwrap. So if I run this way, if it doesn't find it, right, so this is it. So this gives us the first element. In case I also want to get, let's say, the nth element or any of them, I can also do the same thing. Let's get, so there's get there, right? And you can specify what you want to get from that. We can also remove elements from it. So in case I want to remove something, I can just do remove. So let's go with, right, so I can remove by specifying the index to remove, right? So now it's going to be 0, 1, 2, so 6 is gone, and I can also pop, right? So both of them will work. So this, so pop is the last. So now we removed one of them. So in case I'm supposed to print the text again, then now we removed, so it's 2, 4, 6, 8, 10. So 0, 1, 0, 1, 2, 6 is gone, and I removed 2, right? So 2, I removed index 2, which is 6, and then we don't have it anymore, right? So we can also pop. In case I do the pop, pop means take the last value. So if I do that, we are not going to see 10. So if I run it, so we don't see 10 anymore, right? So 10 has been popped out and we only have 8. So these are some of the stuff you can also do in case you want to remove element, and in case you also want to iterate over an element. I can spell iterate, iterating over an element. How do we do that? Over a vector, right? How do we do that? So to do that, just go with my for, right? And notice that this is immutable, right? So I can just do I in, say, odd number, then we have iter. So there is iter, and I can now go with my print, not print line, my print. Then I'll pass in the value I want to iterate over. And see that this join them together as one, right? But in case you don't want to join them together as one, then you just use a print line. Sometimes it will fail. Right, so this works. So this is how to iterate over it. Okay. There is some wonderful stuff you can also do with vectors, right? So let's check what you can do with vectors. We can do so many things with vectors, such as binary search, and then reverse, and then retain, and then all of these basic stuff we can do with vectors. So let's see one example. Okay, so these are some of the stuff you can do. Some of the map. Because I want to sort, so let's say I want to do binary search, so bin search. Oh yeah, I can do even numbers. That's, we have my binary search. Then I'll specify the particular value 2, but unwrap, because it is possible for it to get none. Right, so this is a binary search, and then I can return that. So let's and we got 0, right? So there are so many stuff you can do. You can sort, you can do binary search. In case I want to sort it out, I can just do the even number. So I can sort it, I can do reverse. Right, you can reverse. Right, there are so many stuff you can also do, right? So let me then now it reversed it, right? So it sorted it, you can sort it, and then you can reverse it, right? So there are so many cool stuff you can do with it. Okay, so let's move on from here. I've learned a lot about vectors, I've learned about strings. What about HashMap? So what is a HashMap? So in Rust we don't have dictionaries. Dictionaries are called HashMap. So let's click and see. So a HashMap in Rust is part of the standard library collections framework, and it's a generic collection of key value pairs. So this is similar to what we have in Python as dictionaries, or in other languages as dictionaries. And hash maps are very useful, very useful concept that you have to know, because with hash maps you can do so many things. You can with hash maps you can do so many things, right? So let's see some of them. So let's go back to what I mentioned. So I'll go back here, and then let's hide all of this because we're having so many escaped so file on famous clearing, right? So let's hide all of this. We come back again to them. So let's work with the other forms of collections that we have, which we have it as hash map, right? So hash map is same as a key value pair, which is similar to dictionaries, right? So that's a bit understanding. So it belongs to this standard library called standard library collections, which has so many tools there. So let's import it. We have the standard library collections. There is HashMap, there is HashSet, right? So there's so many of them, but we need just a hash map. So now, how do we use this? Right, so first we'll see how to create a hash map. The hash map is simply like a dictionary, right? So for a dictionary, all you need is something like this. So let's say I have my table, and then let's say we call it as fruits, right? And then to create, you just go with my hash map, and you need to initialize it with the new, and this is how to initialize it. So this is going to create a hash map, and you can see that key type annotation needed for hash map key and a value, right? So we need to specify the key and a value. So most of the case, the hash map keys are like this. So hash map, then it takes in an integer 32, right? So it can be an integer or a string. So let's call it as a string. It can be a string, right? And then an integer, so integer 32, right? Anyhow you want it to be. And this is going to be our hash map, right? Or dictionary. Then in case I want to insert values, how do I do that? So I can just do my fruit.insert, and then I can specify what I want to do. So I want to insert in index 1 some stuff, right? So I can insert, hopefully it works. So let's call it as mango. How many mangoes do I have? I have 1. And then I can also do the same thing. I have apple. I have 3 apples, so something like this. So this is how to work with it, and it's giving us this error. So why is it giving us this error? So mismatch expected string from string, right? So we specified that we wanted a string, but what you are placing here is not a string, it is a string slice, right? So how do we fix it? So we can just do this option here to string. This is one way, or you can do the long approach of the string. So both of them works, right? So either you use this option here or this option here, any of them will work because we specified it's going to be a string type. And then how do we print it? We can now print it out, or we can loop through them, right? So let's see if you go with the normal print, if it work. This is just learning. If we got an error, so what is it saying? So HashMap doesn't implement this display, right? Since it doesn't implement this display, we will need this approach to allow it to be seen. now we can come down here, print, and then we have mango 1, apple 3. Right, so this is how to use a hash map or a dictionary. In case I want to loop through the entire stuff, I can simply iterate through this by going with this option here. So I iterate over the key, so it is my key and a value, and then we are referencing this. So this referencing this here is a reference referencing to what is here, and we're going to loop through the entire stuff. If I run it, see that we have apple 3, mango 1. We can use this approach, or we can also use something like this. So for key, in case I want to get only the key, I want to iterate over the keys alone. I can just go for key in my fruit.keys, and then I can now loop through them. So I print through them, and I can just pass in my key. So this is how to iterate it. I can also do the same thing in case I want to iterate through the values, right? In case I have values and I also want to iterate through them, I can also do the same thing. So we have .keys for keys, and then values for values. And in case you want to iterate the entire stuff, you just reference it and then iterate through them, right? So that is some very simple stuff you can also do with so this is one way, and we have it working perfectly well. There are also some other stuff you can also do. We can iterate and then do some very complex stuff, like check if the value exists. So something like this. You can also do something like this, right? So there is the entry API, whereby we can handle cases where the key may or may not exist. Right, so in case the key does not exist, so let's call it as HMAP, we use this approach here. So what we are doing is that, okay, we create a new hash map, we are inserting A into this, so entry A or insert 0, right? And then this is another way we can also do that. So I can now go back here, yeah, so this is another way we can also do that, right? Perfect. So something simple, something very cool that we can do is, if I do 4, you know that that is what was printed, so that you know that's printed 4, right? So this is it. So this is how to work with hash maps, right? So hash maps are very important. There are so many stuff. So Rust hash map was a cryptographical strong hashing algorithm which can help avoid denial of service attacks. It's however not ordered, so items may not be in the same order as they were inserted, right? So these are some of the cool stuff we can do with hash maps, right? There is also HashSet, right? If I click on this, what is a HashSet? So a hash set, similar to a set, is a collection of unique elements. It's a data structure which stores details in the form of a key and value, and it uses hashing to store elements. So we need HashSet. So what is a hash set? So similar to a set, right? So let's see how to do that. So we can also go back again to our workspace, and then we need to import it. So let's import HashSet. So this is not the correct way of importing, right? So if I try to import this way, to not work. So in case you have multiple steps and you want to import, you can just put them inside a curly bracket like this, and then now we have it, right? So this is how to import multiple stuff in Rust. So with the hash set, what can we do? We can simply see everything like set. So the hash is simply a set. So I can just go back again and let's create one. So we can say select my mutable. So let's go as odd, or say odd set, and then I can just pass in HashSet, and this takes in what I want. So let's go with user 32 HashSet new, right? Something like this. And now I can just insert. So how do we add to a set? I can just go with my odd set dot insert, just like we did for the dictionary. Then I can pass in my odd sets here. So we have 1 odd set dot insert 2 3. So this is how to do that, right? And in case I want to loop through them, I can just go with this option for value. Remember that it is a collection, so we need to do this approach, right? And then it's gonna work. So odd set, and then we get them. So this is a set. And in case I want to loop through them, so for I in my odd set, we can iterate over it in several ways. So there are several ways we can iterate over it. We can just say this to my value, then print line is another way, right? So this, we can also iterate through it, right? So we can iterate through it through this way. And there are several set operations we can do. We can check if one set is another subset of the other. So let's say we have an odd, we can combine sets together. We can do superset. We can do all the various methods that we can do with sets, right? So in case you want to learn more, you can check it here, right? So if I click on this, we have, this is a struct. We have an example of a set. We can insert values. You can check if it contains some specific values here. We can remove, right? Very cool. And then we can also create some basic stuff there. So you can check the capacity. We can check if it's a superset or subset. You can check the length. You can check if it's empty. We can drain it. You can extract if there's something. There are so many stuff. Okay, so we have seen how to work with these 3 data structures. So this is mostly some of the basic cool stuff you have to know when working with Rust. Let's move on from here to control, right? So now let's go to control flow. So this is what we had here. So we have seen this. These ones we will learn them later on, and these are advanced stuff, you learn them later. But if I go to the control flow structure in Rust, control flow is managed through various structures like if, else, while, for, loop, match, if, let. The if and else structures are used to execute different blocks of code based on certain conditions, right? Similar to other languages, while and for are used for looping. So let's see how the control flow works in Mighty Rust. Okay, we have control flow. Control flow is very important to know and understand because most of our logic and how humans think is mostly control flow, right? So let's see how to do that. So first we go with the if else. So first, let's say we have a value called x. So let s be equal to 20 and let y be equal to 25, right? So this, both of them are signed integers, right? And in case you want to use control flow, we can do something like if s is greater than y I want you to print line to s is greater than y, right? And then we just do sy here, s here, and then yeah, something like this, so that we know the value that you are checking against, right? So if this is correct, then do that. So this is a simple if condition. So if I run this, we see that we got hello world, and then we have some unused stuff there. So let's go up and let's hide all of this. Basket, we don't need it, right? So if I print it now, the reason we are not getting anything is that s is 30 and then y is 25. So I can just do else, do the opposite. S is less. So if I now run this, we are going to get the final value. So S20 is less than Y25, right? So this is how to do a control flow. So if this, else this. We can also do multiple if. So else if, so we have else if. So we have 3 conditions. So if this, do this, else. So something like this is also possible. We should not forget to close this. So else if s is equal to y, we won't say s is equal to. Right, so now if I change this one to 2020, we see that we have the if condition, else, right? And then I can run this, and then you see that, so S20 is equal to Y20. So this is how to do a simple control flow, right? Let's see how to do a for loop. So there is an infinite loop, it's a normal control flow. Then we have the loop, so we have an infinite loop, which goes something like this. So as long as I is greater than 100, continue to print everything. As if I is greater than 100, then you break, right? So this is something that you can also do, and this will keep on printing till it reaches, right? So let's save it. And you see, okay, here a local variable with a similar name exists, right? So we have I. Let's ensure that we don't have any variable with y. So the reason we are having this error here is that we have to define this first, right? So that it can work. So let me define this. So let's code this. Let I mut I be equal to define it, and let's see. So I'm going to specify this is going to be 2, and let's run it. So just to keep on running for the end of the world, right? So because this is 2, so if I is greater or equal to 100, break, but if it's not, to keep on, right? So this is one way. So let's stop it. So this is a for loop, infinite loop, but we can also do a normal for loop. So this is a for loop. For loop is very useful for many things. So as long as a condition is met, keep on doing it. So there are several ways. So let's say we have a value. So let's say this is my salary, right? And then this my salary is an array or a string, right? So if it's an array, I can just say my salary is say 6,500, say 5,800, something like that, right? So let's say something like this. In case I want to loop through it, I can just go for I in my salary, and then I can loop through it. So print line. This is how, I think we have already seen this before, right? Then I'll pass in my I here. This is how to do a for loop. So far we are going to loop through the entire stuff, and then we are going to get our value, right? So this is looping through it. We can also loop through using range. So how do we do that? So we can do something like this. So let's say I have for I in, let's call it as 0 dot say 20. So from 0 to 20, then I can do something like this. So let's go back with this. So if I go back, and then so it's also going to loop through it. So this is another way. So we are looping through a range, right, using the option. And then we can also do some enumeration also. So in case I want to enumerate, I can do something like this. So for C, V, and C in this range, dot enumerate, so we're going to loop through it. If it's up to this point, we continue. So we can use for loop together with if conditions together with continue. So now we have this nice result here. Perfect. So that is how to work with loops and then conditionals, right? So let's go back again. So we have seen how to work with if, else, while. There is also while loop, which can also work on. There is also loop and for, and there is also match, and then there's also if let. So these are also very wonderful concepts in Rust that are very useful, that you can do so many things with them. So let's see a simple example of how to work with a match condition. So we can also do the match, right? So let's see what it says. Rust match structure, which is similar to switch. So in Python, there is switch. In some language like C# and stuff, there's also switch, right? But and then module. But match is similar to switch element in other language, right? It's powerful to use for pattern matching. It checks through different cases defined by the programmer and execute the block code, right? So let's see an example of how to work with a match. So we can simply work with a match like this. So the idea behind a match is that you have a pattern and then you want to match that particular pattern. So let's see an example. I'll go back again to our workstation here. Let's hide this one. Paske we don't need it. Patamushta etani nada. Okay, so let's see their match. So how do you work with match? So to work with match, let's say you have a number called number 7, which is a sign 32, and then I want to match this number. So match this number, and there's the order. So we are specifying that we want to match this pattern. If the matched pattern is met, if it's this approach, if it's 1, I want you to print something. So 1. Right. If it is 7, we just put a bracket. If it is 7, I want you to print line 7. Right. And then finally, this is a catch-all. So we use this underscore to catch everything that is not match. So print line per the pattern, which is going to be other. Right. So that is all. So this is how to work with a match. So we specify the number, and then you say this is similar to if number is equal to 1, print this. If number is equal to 2, print this, right? So it can be done like if the number is equal to, let's say 1, then print line something 1. So else if number is equal to, so something like that, right? So all this long stuff, we can simplify it with this much, right? And then we can now run. So let's run this, and then you see that we have 7, right? So this is how to use match. So match is very useful. We can use match with enumeration. We can use match with multiple patterns. We can use match against multiple patterns. So this is an example of multiple pattern matching. So this is we are using against the pipe operator. So you are saying that, okay, if number 3 and 1, so we just, if it is either 1 or 2, print 1, like that, right? So you can also do something like this. And then we can also do matching with binding, right? In which you bind it to a particular value. So let's say something like this. So this is normal one with binding. So in that case, we are saying that, okay, we have none or optional, right? So we have, right? So we can match it, so some number, and then stuff, right? So we can use match like this option. We can use it with multiple pattern matching by specifying this. We can use it against enums and struct. We can also use it with binding, right? Very cool. But in case you want to ignore, you can just use the none, or you can use the underscore. Okay, this is some very cool stuff we have done so far. Now there is also iflet. So what is iflet? So iflet is similar to match. Iflet is similar to match, and it allows you to match a value against a pattern and execute the code if the pattern is met, right? It's similar to match. So how does it work? So let's see an example of how to use iflet. So as we saw here, so the if-let syntax lets you combine if and let into a less verbose way to handle values that match one pattern while ignoring the rest. So it's going to match one pattern and then it's going to ignore all the rest, right? Without caring about the rest. So that's a big understanding. So the basic idea is this. This is my little understanding of it, if-let. So it's if-let allows you to match a value against a pattern, and you execute a block of code if the pattern matches and it ignores the rest. So let's say I have something like this. So there is one data type we forgot, which is the sum. So this sum is also another data type, which is very useful in Rust. So let option be sum, right? 5. So if let sum s is equal to a pattern, you print that particular value. So let's see. So the value says, so what it's doing is that the sum will be executed, right? So if the option is sum 5, so what you are doing is, okay, let sum x be equal to this option, and if that condition is met, return this, right? So that is a basic understanding. So it's a very powerful stuff. So with time you will learn more about this option of using if-let. Okay, so let's go back to our roadmap and see some other stuff we can also do. So we have seen all of this. We have seen vector string, HashMap, HashSet. Now let's move on to enums. So we need enums, structs, and then functions. So let's see how to work first of all with functions. And throughout all that our learning, we have done so many stuff. So all that we have been doing is inside this thing called fn. What is fn? So fn is function in Rust, right? So let's see how to work with functions, and then we move on to the rest. So let's check our roadmap, And then let's go back here. We have functions and methods. So what is a function? In Rust, functions are declared using the fn keyword. Each function can take a set of input variables with their specified types and may return data of a specified type. The body of function is contained within curly brackets, unlike other languages. So let's see how to work quickly with functions in Rust. First, I'll go back in, and then we will hide all our control flow. And then we move on to work with functions. So what is a function? Right. So in Rust, we just define a function with something very simple. So let's create a function. So I'll create a function outside of my main function. So fn, and I'll call it that, let's say, print first, right? So this is a simple function that takes in some term, and this term is going to be a string slice. So the reason we are using a string slice is that we want to point and then be able to do some other stuff, right? So it's always useful to use that. And then now I want to return the first, so print first. So I can just say return, then I'll take in the term that I have, then I want to get the first value from that, right? So we are trying to combine all that we learn to return that. So this is it. But notice that once I do this, we get an error. So a mismatch. So expected dash. So anytime you do not return, you should, all the functions, right, should have a return type, right? So let's return the type. If I save it, now we have our return type. So now let's use it. To use my function, I can just go back here, and then let's say let pf be equal to print first, and I'll pass in my term. So let's pass in some wonderful term. So the term I want to pass is a string literal, which is going to be, let's say, this is cool, and then let's print line. Pf, right? So if I go with this now, we can see this function working. So this is a function that takes in, the function takes in some variable, right, some data, and apply some function to it, and then return it, right? So if I take off the return, the last value that is returned is the last statement is the return, right? So you should always put it there, right? Okay. That is some very simple stuff about working with functions. Of course, there are so many things you can do with function, but it is one function, one way of declaring a function. You specify fn, specify the input type or the parameters together with the data type, the return type, and then you can do whatever thing you do there, right? So that is how to work with functions. Okay, so we have one here. Right, so that is the basic understanding. Let's go back from functions. You have seen how to work with functions. Let's see how to work with enum. So what is an enum? Right, so we will first work with a struct first. So what is a struct? A struct in Flux, I said in Flux, in Rust, we do not have classes. What we have is a struct. So in Rust, a struct is a custom data type used for grouping related values together into one entity. So structs are similar to classes in other languages. Essentially, each struct creates a new type that we can use to streamline complex data handling. So the custom data type for grouping one entity. So apologies for that. So this is how to work with functions, but let's see how to work with struct. So I'll define my struct outside of my main function here. So what is a struct? A struct is a custom data type used for grouping related values together into one entity. So it is so useful that you have to know it, right? In case you want to excel in Rust, there are so many things you have to know, but one of the most important things you also have to know is how to work with struct. So let's see an example. So let's say I want to create a struct, right? So how do you create a struct? See how to create a struct, and then a struct can have methods, right? Right, so a struct, you can create a struct, and a struct can have methods just like classes, right? So to create a struct, you just go with struct, and then let's say I'm going to create a struct called atom, or something like that, right? So a struct called an atom, and then this struct has, every atom has a proton, and the proton is, let's say, the number, and then it has an electron, something like that, right? Which is, or something like that, right? So protons, number of protons and electrons. So we can also say 32, right? So this is a simple struct, the struct called atom, right? And then we can, how do we use this struct? So to use this struct, all you have to do is just go back here. So let's bring it, I'll copy the struct. Okay, so I want to use a struct here. I can just say let A be equal to my atom. Then I'll pass in my values. So I want to pass in the value. So proton is equal to 6, and then the electron is equal to 6. So this is how to create an atom, or not an atom, a struct, right? So while passing the struct, original diagnosis missing for electron in, yeah, we have to put it here, right? And now we have our struct called an atom. Now I can print line. If I go with this option here, notice something. We get an error because we implemented our own custom data structure called an atom. It does not implement a trait, right? So we have to use this option here to allow us to be able to print it. So if I run it, let's save, and let's see some funny stuff. So it's saying that, okay, yes, although I'm using this option here, but it cannot retain the values there. Why? And that is how useful the Rust compiler is. It gives you a lot of information. So let's read it. So it's telling me that, okay, this inside this file on line 26521, so line 265, so which is here, 265, line 21, so we count 0, 1, 2, 3, blah blah blah, 21, we have a format, so cannot be formatted using this option. So help, the trait debug is not implemented for atom. So debug is what is used to print, right? So note, add debug to atom or manually implement debug for atom. So by implementing debug for atom, you can do this, or you can add this macro. It's how to define a macro or decorator. So like something like a decorator in Python to decorate the struct with this particular feature, right? So this error originates in a macro, right? Because it doesn't have it, so we need this on it. So now I can pass in my debug on this, and then once I do that, see the error goes, right? And now I can print it, and now we see we have it printed here. So this is how to work with a struct in Rust. So you create it like struct, and then you go back. So in case I want to access one value from this, I can do this dot proton, and then I can just get the first value. I don't even need to do this. I can just go with this option here, and now we have number 6, right? So this is very, very useful to work around, right? So structs are very useful. You can even implement functions on a struct. So let's use another one. So let's do something like this. So I'll just copy this, and then we'll see how it works, right? So that is one way. So let's create this. Is okay, but let's create something better than this. So I'm going to create another struct. I'm going to call this struct as a student, or let's say as a human, right? So this struct has a human, and then every human being has a name, which in our case is a string, and then every human has an age, and that is the date of birth, which is going to be integer 32, and then every human has a gender, which is going to be string. You can say true or false, right? So something like this. So this is a human struct, and then I can add the derive class to it, the derive debug class, or not class but macro, to decorate this. And then in case I want to add a method to the struct, we can do the same. So in case I want to do that, so there's one, there are several ways you can do that. So just like you could see struct like you can see struct like Python classes, right? You can see struct like classes. So let's see what we have here. So classic C struct are named field struct and are the most common used. Table struct, while not being common, are useful when you want to couple together. There is unit struct, and there is also other forms of struct, right? So in Rust we have so many types of struct. So let's see. Yeah, perfect. So first we can implement some structure, right? So let's call it as my constructor method, right? So to do that we need what is called the implement. So imp, so this option here is used to add a method to a struct, right? So implement, that's the meaning. So implement to this struct. This is similar to do something in Python. So class, so human, right? In Python you would have done something like this, and then you would have done so def init self, right? And then you just go, let's say name, age, gender. Then you would have done self dot name, go to name, self dot age, go to age, self dot gender, go to gender, right? So this is how you'd have done in, and then you'd have done rep self, then let's say you just return something, so human self whatever blah 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 blah, right? So something like this. So this is in Python, right? And in case you want to create a method, you would have done, let's say, another method like, say, get name. So self would have been, so return self dot name, right? Something like this. So this is in Python. Now in struct for Rust, you don't need to do this. So this you have done here is equivalent to this, right? And then this representation, you can also implement it, but you can also use this debug to do the same thing. And then this get name, we can now do that. So in case you want to work on something like this in Rust, in class Python, we have this initialize, and then we also have def new also, right? There's also something like this in, but we can also do something similar to be able to create a constructor method in Rust. And you do that with implement, that is implement for implementing. Then you specify the class or the struct. Then you just go with fn new. So once you do fn new, you can now pass in your value. So let's pass in the name, string, the age, height 32, and then the gender string. And then we are returning human. And this is going to be human. Then we pass in this, right? So we can have something like this. I can just go without this option, right? So we don't need this. Right, we can have something like this. And once you do this, that gives you the option of doing something like this in Rust. So I can just do, let's say, let h1 human1 be equal to human new, right? And I can now do something like this, right? So by doing this option, now we have this method here. So this is how to call the method on it, right? Dot, and then this particular method. And then I can pass in some stuff there. I can pass in the name. So we can just pass in some stuff. I hope it works. So this is it. Age. Sometimes I don't know whether we should do this or we should do this. And then the gender. Now in case I want to print line, remember that this requires this option, and because we have the h1, I can print. And now it's giving us this error. You might have meant to introduce a new binding let, right? So this is something you can do. Hopefully it's this way. So it's giving us this information, which is quite interesting, right? So I think I don't even need to define all of this. All I have to do is just I don't need this, right? And why am I getting this error here? The reason is that in this function we have strings like this. So I have to do the string from, right? And then I'll pass it here. In this case it is valid, right? So now there's no error. And I can also do the same thing here. And now we have it. So this is how to implement a constructor method using this approach here, and then we have this option here. Now if I run it, we have it working perfectly well, right? So that is how to add a method to a struct with a constructor method. We can also add more methods, so it's not just this one. We can add other methods, like let's say getter methods. can add a method here. So fn, so get name, and this one, so the first one here took in nothing, right? But this one is taking in the self. So self, and I'll return, what am I returning? I want to return a string, and then this string is going to return so the other one. So I can just do return like this and return myself dot name, right? Which is similar in case you're coming from Python. So that being something like this, right? Exactly the same idea. But why am I getting this? So let's listen. So expected a string found this type of string. So that is why we are getting this error. So what we can do is that we can fix this issue here. We need to return this as a return type, right? Because that's what we are returning. In case I want to return just a string, I can now do this. And then it works somehow-ish. But let's return the reference to the string. Right, you're always returning the reference to the string. Right, so this is how to get a method. And now in case I want to get this method, I can just do here. Let's copy this one here. Get name. And then if I print it, we're going to see we have the name here, right? So we can actually add a method. You can add a constructor method. You can add a normal method. So say get method. But of course, so this is, you can also add a setter, right? So this is just a getter. You can also add a setter method. So let's say I want to set the age. Can do something like this. So set age, I make this mutable, so the self is mutable, then I have age, and then I can change it, right? And then in case I want to do that, I can just go back here. We set the age as 3, but in case I want to change it, because we have a setter and a getter, we can actually change some stuff. So we can do something like this. So we have h1 dot set age. So you're saying I cannot borrow h1 as person. Why can't we borrow it? Because it's not mutable, right? So for me to be able to borrow, I have to specify that this is mutable, and now I can borrow it, and then I can now print it out. So if I print it out, so initial one was 3, but now it is 31, right? Very cool. So these are some of the cool stuff we can do with struct, right? So of course there are many things you can do with struct, but these are some of them that I wanted to share with you. Now let's move on from struct to we saw the implementation block. So imp block uses the imp, right? impl implement keyword, and I used to implement behavior in the form of methods for struct, enum, or trait. If you want your data type or struct to have method, you need a corresponding imp block contain. Note that the self and self have different meanings in the context of an imp block function. Self represents the specific value of program that's calling the method and passing self as an argument, while self is sent as sugar for implement the type. So what it means is that we have here, we had this option here, right? So we can also use self, the big one that returns self, right? I think this is also correct. We can also use this option here, right, to return the whole stuff there. That is, as far as I remember, this is correct. Okay, so that's what it means, right? And then let's go back again, and we have the implement. So the implement is this that we saw. Okay, so let's see how to work with enums, right? So what's an enum? So an enum, short for enumeration, is a custom data type that allows you to define a type by enumerating list one by one of its possible variants. right? So let's see, how do we work with an enum? So I can just go back again to here. You've seen how to work struct. How do we work with an enumeration? So did I just go with my enum keyword, and then let's say enum has, let's say it's a direction, and what are the different directions? It can be up, it can be down, it can be up, down, it can be left, and then right. So this is how to define an enum, and then we can use it like this. So let my direction be equal to direction dot up, right? That is it, and then I can just print it out. We can use the same enum, we can combine this enum idea with a match, right? Because in case you want to print it, we have to pass in this here. Then if I run it, we have our app. So this is how to work with enum. Of course, there are many things you can do with enum, but that is something I wanted to share with you. I hope you have learned something. So let's recap on all that you have learned. So we have learned about enums. You can use enums with a match block. We have learned about struct. We have learned about the implement block. Let's go to traits. So a trait in Rust defines behavior that are shared among different data types. So implementing trait for data type is a great way to group method signature together, right? So this is how to implement traits. So traits are very useful, right? It seems very useful in case you want to use for inheritance. Okay. So thank you for watching this tutorial. I hope you have learned something. So we are almost about 2 hours in our introduction to Rust, trying to learn the basics of Rust. So let's see the final stuff with traits, and then we'll be done. So I'll go back again to our workspace here. So we already have our struct, right? So let's say we have this struct called human, and if we want to implement a method, we have the method called human. So let's say we have traits. So how do we work with traits? So with traits, you can use it for inheritance. The same idea with inheritance, you can use it for that. In case you have a struct and you want to share similar properties, you can use traits for that. And in case you have, let's see, I have human, right? So we had our human enum. We had our human enum here. So this is our human enum, and we created an implementation for it. But in case you want to share a trait with this, we can simply do something like this. So traits, not traits. We can do something like this. So pop means public, traits, person details, and then we will define these functions or methods, but we will not, these are just signature, right? So what the trait has, we are not going to write the real implementation. Anything that is going to inherit this trait is not going to define these particular methods. Now, how do we apply this person details for the human struct that we have. So remember that we had our human struct there, which is this one here, and then we want to apply this trait to this. So to apply this trait, we can just do implement person details for human, right? And that's how we do it. And then remember that this trait, this person details traits, had these three methods. Not for, it has get name, get age. So now you are now going to implement it. So fn, so get name, and then now I can now implement it. So this is self.name. This is supposed to be, yeah, right? So this is how it works. So instead of not all traits implemented for this. So how do we fix it? We can just see, let's close it. So not all quick fix. Now it's going to, so in case, it's so funny, I never knew there's this code to do. So this is how to implement all the different methods for that. So let's save it. The reason we have this error here is that we already have it defined. So let me hide it here. Right, so this is how to work with it. So we have gotten our human, and we have implemented the person trait for this human, right? And then we have this one, this one, this one, and the rest. So I can actually do it better. Instead of doing the to-do, I can just do this, and then we have it well implemented, right? So this is how to implement this trait. So now the human being has all of these features out of the box, and then we can actually share it. So I can just simply create something like this. So let's person human, then John Doe 30, age male, and then now we already have it. In case I also have something like, so this is a human, right? I can also create another struct. It's like inheritance. We call it as trait inheritance. So I can just do, this is no more human, this is, let's say, an angel, right? Angel has a name, age, and I can also do the same stuff we did, the same implementing for that. And they have the same thing, they can share the same properties, right? So this is this type of inheritance similar to composition, right? Instead of just inheritance. So this is how to work with traits in Rust. So thank you for watching the tutorial. In case you have any questions or contributions, you can put it in the comment section below. So you have seen how to go through this workflow with introduction, how to work with these various data types, how to work with control flow, syntax and semantics, functions, pattern matching, and then some various stuff and also some of these stuff. So in the coming tutorial, we'll try and see how to continue with some of these stuff. Mostly we move straight away to the application, right? So thank you for watching. See you in the next session. Stay blessed. Bye. So let me save all that we have done so far and then commit it, right? So I'm just going to go back here, clean up the code. So let's go all the way here. We want to keep everything for future records. Perfect. then yeah, something like this is better. Okay, so perfect. So let's get out of here. Git status, git add all, git commit -m -core. So let's call it as feature dot basics, and then data structure, then git push, so that we have it for future record. So if I go back to my Git roadmap, if I refresh, I have it here. Then if I go back here, you can see that which we did, right, which is there. So these are all that we did for the course so far. So thank you for watching. See you another time. Stay blessed. Bye.